Algebra 2, Target 30, I can graph rational functions. Today, the focus is going to be on graphing functions that are in the form a over x minus h plus k. You will probably see it more written like this, where a over x minus h is a fraction, and then k is added out over top. I mean, this is the same thing, just generally it looks like that. All right, we need to remember that all functions have a parent function that they look like, and we do different shifts to. The parent function for the rational function is 1 over x. The graph of 1 over x, right here, it kind of hugs the y-axis from the left on the negative side, and then it decreases, kind of curves, and hugs the x-axis from the negative side, goes down and hugs the y-axis. Same thing as we continue, starts on the y, curves off and hugs the x. That action where it's really close, that's called your asymptote. At the extreme, the graph is approaching y equals 0 and x equals 0. So all rational functions have two asymptotes, one vertical and one horizontal. Now what happens when you have the h and the k, just like in any other function, when you add something to the x, it's going to shift it left or right. And when you add something outside of the function, it's going to shift it up or down. So the h and k are the shifts, left, right, up, or down. So to graph these, we're going to see what our shifts are, and that's going to tell us what our asymptotes are. So find your shifts and draw your asymptotes in those locations. Then we're going to plot a couple points, like you should with all graphing. Plot a couple points, see what's going on, and then connect them. You want to get a nice smooth curve in the proper locations that hugs the asymptotes. So let's look at an example. We're going to start, what are the asymptotes? All right, h here is -2. That's our vertical asymptote. Remember, it's the opposite of what you see in there. So our vertical asymptote here is at x equals -2. So we'll graph that. So take our vertical asymptote, it should be at -2. Our horizontal asymptote, right there, k equals -1. So that is our horizontal asymptote, y equals -1. We'll take that, we'll shift our asymptote down. So those are our asymptotes at -2 for the vertical and -1 for the horizontal. So we'll make a table. I'd recommend looking at your vertical asymptote and kind of surrounding it. So our vertical asymptote's at -2. We'll do a couple on the left and a couple on the right. Now we know at -2 it does not exist. So I'll put an empty sign there. And then at -3 we'll just try some numbers, put it in, what do we get? At -3 we got -4 over -3 plus 2 minus 1. This right here is -1. -4 over -1 is 4 minus 1. And that gives us 3. All right. Let's try at -4. Get -4 over -4 plus 2 minus 1. This is -2. -4 over -2 is 2 minus 1 is 1. We'll try at -1. -4 over -1 plus 2 minus 1. -1 plus 2 is 1. -4 over 1 is -4 minus 1 is -5. Then we'll try at 0. -4 over 2, because the 0 just cancels the x. So that's -2 minus 1 is -3. So let's plot those points and see how they compare to our asymptotes. Okay, so -4, 1, -3, 3, -1, -5, and 0, -3. And we can see we kind of hug through this region of the graph there, and that region of the graph there. And there's our rational function. All right, let's try the same thing on this next one. Nothing's added or subtracted on this one, so that means our asymptotes don't move. So that one will stay there, and the vertical one will stay there. So our asymptotes are x equals 0 and y equals 0. So make our table and plot a couple points. Remember, we want to kind of use 0 as a starting off point and check a couple on each side. Well, if we stick -2 in, -4 over -2 is 2. If we stick -1 in, -4 over -1 is 4. If we stick 1 in, we get -4. If we stick 2 in, we get -2. So we'll plot those. -2, 2 is right here. -1, 4 is right there. 1, -4 is right here. And 2, -2 is right there. We plot those. And we can connect those, and we got our rational graph. Pause, try this one, and I'll go over it. So we take a look. There's no shifts left or right. I'm sorry. There's no shift left or right. So that means our vertical asymptote is at x equals 0. There is a shift down 5, so that means our horizontal asymptote, that's at y equals -5. Right through there. So let's make our table. I want to surround 0, so I'll do -1, -2, 1 and 2. Plug in a few values. If I plug in -2, 8 over -2 minus 5. This is -4 minus 5, that's -9. All right, let's try -1. 8 over -1 minus 5, -8 minus 5 is -13. And if we plug in 1, 8 over 1 minus 5, that's 3. And 8 over 2 minus 5 is -1. So we got our points. Let's plot them. -2, -9, -1, -13, approximately there. 1, 3, and 2, -1, and we can see our curve roughly goes like that. Pause, try this one, and I'll go through it. All right, first find your asymptotes. There's a shift right 3 here, so our vertical asymptote is at x equals 3. There's a shift up here, so our horizontal asymptote is at y equals 2. Let's sketch those. Y equals 2 comes through here. X equals 3 comes through here. We'll make ourselves a little XY table. Remember, we want to surround our vertical asymptote. So 3 will be a starting point. We'll do 4, 5, and 2, 1 on the other side. 3 does not exist because it's an asymptote. If we plug in the values, let's plug in 1. 1 over 1 minus 3 plus 2. This is -1/2 plus 2. That's 1 1/2. If we plug in 2, we got 1 over 2 minus 3 plus 2. This is negative 1 plus 2 is 1. Plug in 4, 1 over 4 minus 3 plus 2. This is 1 plus 2 is 3. And finally, we'll plug in 5. 1 over 5 minus 3 is 2. That'd be 2.5. All right, so we'll plot those. 1.5 is here. 2, 1 is here. 4, 3 is here. And 5, 2.5 is here. And you can see this one's really close all the way throughout. And that there is our rational graph. So in conclusion, how do you graph these? All right. So the first thing you need to do, plot the asymptotes. Look for your shifts. On the bottom, left to right, that's your vertical asymptote. Outside, up or down, that's your horizontal. Okay? Then plot a few points on each side of the asymptote. Pick them close so you don't get large, outrageous numbers. Then connect the points so they make a smooth curve that approaches the asymptotes.